I don't know if all the people who will be here will be on time. So maybe we should wait a little bit for everyone to drop in. So let me just use the first minute or so of the call to introduce ourselves. So welcome to this event. It's the 7th of the series. So my name is Chris. I'm from Token Engineering Labs. We are hosting those events for quite some time now. Some of them have been in present. So we've been doing this before COVID. We've been doing it by meeting in a conference room or in a university lecture room. But now we've decided to go public with them and share our knowledge and our interest with as many people as possible. So, so this is what you can expect from us. One of our activities will be this meetup series. And today I have the pleasure to invite Mark from the ETH. So while people are dropping in, maybe Mark, I can hand over the microphone to you and give you the chance to introduce yourself, and feel free to start whenever you feel that you're ready.
Okay, thank you very much for the opportunity to talk to this group. Very much looking forward to it, in particular, as I'm probably having some knowledgeable people like from the blockchain space, and yeah, I always love to have these interactions. So I'm planning to talk like for roughly 60 minutes, plus minus. I probably have too many slides than too few, so probably I will skip some in between. And regarding questions, so if you have something which is really you want to ask immediately, feel free to interrupt me. If it gets a bit out of hand, I will maybe not answer all of your questions, and we will have like a discussion round in the end. And in general, so I'm, as Chris already said, I'm a postdoc at ETH Zurich. I recently defended my thesis, which title you can read here. My background from my educational side is more in high performance computing. During my research, I did it a bit less. Yeah, you will see what I did there. And I'm also having a second role. So I'm contributing to Onokoi, which is a blockchain startup. And in the end, I will also very briefly talk about Onokoi. And maybe you will see. I think it will be interesting. And if there's nothing in our way, I would start with my presentation. So we will start now with the presentation. So just like illustrating myself a bit in greater detail in one sentence, I'm a computational social scientist who has like a complexity theory-based view on cryptoeconomic systems. Okay, so I'm computational social scientist. So what is it? So like very briefly, it's like kind of merging these two worlds of computer science and social science, researching objects in both of these fields. In particular, cryptoeconomic systems, I see them as having this technology distributed ledgers and also using cryptoeconomic incentives. And I'm researching these systems with lab experiments and simulations, and more to follow. Nevertheless, first to the motivation, so complexity science, and here usually like motivating my research and my work, one can take different entries, and usually I'm not choosing this one, but I'm very much looking forward to it because it's like actually my favorite one. So what is complexity? So when one takes a network perspective, complexity can be illustrated with such a linked graph. And actually the property of these complex systems is that actually not the single dots in these networks are the deciding factor, but more the links between the dots. So in the past, maybe this was different, but nowadays we're increasing the links, like we're adding over the internet, many of these links, but also in the physical world, like our movements pattern changed. And so this complexity is increasing. And through this property, we actually observe counterintuitive effects. So very often a small impact or change in the network can travel through the network and has very huge impacts, also known as a butterfly effect. But also the opposite case can happen. Changing many parameters often does not change anything. So, and these are very counterintuitive for us humans, and actually the properties in these complex systems are often emerging. So by analyzing just some local subnetworks or just some local dots does not explain how the system behaves overall. And actually, through this, many things can emerge, often very positive ones, but also negative ones. So we have these global challenges currently on our planet, like from pollution to social unrest. And actually, one question which naturally arises and drives us all crazy: how can we address these challenges effectively? And here, taking a step backward, one actually needs to answer two questions. So actually, who can know which challenges should be addressed? Yeah, and in which order maybe? So kind of a normative decision. And then if we have decided what we want to address, how do we implement it? How do we control for it? And so let me give you an overview how we did this usually in a traditional way. So traditionally, we had these institutions. So far in the past, we had the church. They had a holy scripture, so to say, and a priest caste who knew how to interpret it, and they basically knew what was good for us humans. So whom we can love, whom maybe we can't love. So like kind of they decided, it had the knowledge. This got over time, one can say, replaced by the state. So the state now has kind of a scripture, the law, which is maintained and interpreted by a new caste, like the lawyers basically, and they can identify, for example, what's a good consumption and the bad one. And recently, these institutions get more and more replaced by corporations. So like in the context of fake news, like the programmers now, they can write actually code which can identify these misinformation and also address them. So this is like kind of a change. And very recently, one could also say maybe academia is playing a greater role, also taking these normative decisions. And what one very often can say is that because not everyone is included in this decision making, at least for some minority groups, some of the decisions are perceived as unfair. And so this is one of these problems here. And then how to implement. Also here, traditionally, we used hierarchical organizations. And these hierarchical organizations are actually very efficient in implementing stuff as long as the environment is not changing too much. But what we observe is that actually when the environment is changing a lot, these systems often break, so they are less resilient to changes, which is very often to too long feedback loops or to broken feedback loops, so that the system cannot adapt. And what is the consequence of this? So actually, it's my favorite example, which I'm always taking. It's from Germany. So we as a society, we actually identified, hey, we would like to reduce CO2 emissions. And how did we implement this in Germany? And so what we did, actually, we used a top-down policy. So on the one hand, we introduced or we subsidized the power production from biogas plants. So it's heavily subsidized. On the other hand, we made the petrol station owners sell fuel which has some ethanol, so some plant-based fuel in it. So also via punishments and not by subsidies. And these were very good intentions with the plan or the intended effect of reducing CO2 emissions. Nevertheless, what we observed was kind of a side effect. So when one travels through northern Germany, where I'm also from, one very often observes these huge monocultures, because what actually the farmers did, because of these subsidizing and actually basically subsidizing this plant production for fuel, a lot of these plants were planted, which in the end endangers kind of biodiversity, also the groundwater levels there getting worse and worse. So there were some kind of side effects to this policy. Nevertheless, we also had a cascading effect, because like in the past, farmers in northern Germany, they produced animal feeds for the animals on their own. So they were produced locally. Nevertheless, because now we use the land to produce these plant-based fuels, this animal production got outsourced very often to South America, where actually it resulted in also in the cut down of the rainforest, which kind of had a very long-ranging negative feedback loop. As we all know, the Amazon rainforest is a great store of CO2. So these are like basically things which we observe. So like very intuitive things often don't work as well. And what one can say is that actually these old approaches are failing in an ever-increasing complex world. So basically, the knowledge often does not lie in centralized entities and institutions, and actually how we control for it via these hierarchical large organizations often comes also to its limits. And this would be now a very sad message if I would stop talking here. But of course, we have solutions for both of it, inspired by complexity science, one can say so. So the one for the normative decision making, one can use a concept called collective intelligence, or also known as wisdom of crowds, which can be observed in repeatable lab experiments also. So basically what it says is that actually very often the knowledge lies distributed in many people, and that collectively, if one is able to harness this knowledge, that this can outperform even the knowledge of secret agencies, as a very famous project in the US demonstrated. So kind of one can use this concept for what one needs here is actually that the crowd, the collective needs to have a free access to information, privacy to reason about the assessed information, and also kind of having the right to free speech and to express their opinions freely. And so when one designs this well, one can obtain this collective intelligence. And on the other side, for the controlling part, one can use a concept which is called self-organization. It's actually very simple. So what one needs here is kind of real-time feedback. So something or someone behaves, changes environment, and immediate feedback is obtained. And one example, or the prime example, is always a flock of birds. So the flock of birds is kind of moving through space, and it's actually very hard to simulate, but actually the underlying governing mechanisms are very simple. So like a bird, if it's too close to another bird, flies away. And if it's too far away, it flies back to the bird. And through this, the flock is moving. And it actually has very beneficial properties, one can say. So they can protect very well against predators. They also find food resources very easily. And in my opinion, the nicest property is actually that this flock of birds is very resilient. So there does not exist kind of a controlling bird which is steering the movement, which could be maybe shot by a hunter or killed by a predator. Which would then lead to the destruction of this flock because it simply doesn't exist. So it's a very resilient structure. Also our human body is working like this, our immune system is working like this. So there in nature, very many of these systems which work with this self-organization. And now is the question, can we also use these in our technical and our socio-technical world? And there has some research been performed also by my group. And what we actually did was like to apply the self-organization principle to the traffic light control in a city. So very often traffic light is controlled top down. So you have a central agency. They plan the traffic. So they basically say, hey, we have a morning traffic, after football match traffic, something like this. And then they try to implement green waves. But very often actually this fails because situations are very unique and it's difficult to plan for all of them. And so what we did in this experiment was that actually each local traffic light can decide on its own how to optimize the traffic flow only by communicating with its neighbors. So it was allowed to communicate with neighbors, but actually no entity in the overall network had the overview of what is happening everywhere. So it was just local interactions. And actually the average waiting time for all participants reduced. And you can even in this setup very easily prioritize different parties. So for example, you can public transportation, you can prioritize, and then you have a huge decrease. Nevertheless, it just makes sense for everyone. So the self-organization is actually highly effective. And here, now having these two things in mind, actually, naturally, there are like two possible research directions. So we can use technology kind of to make these hierarchical efficient systems more resilient. So this has been tried a lot and is still being tried, I would say. So what one can do, one can use big data, machine learning, AI, trying to predict the future so that some centralized parties can make the right decision to steer the system in the right direction. And this is definitely, I think, possible. So I think also this is a normative decision. But on the other hand, we could also use technology to make already decentralized structures which we're having more efficient. So via this collective intelligence, via self-organizations. And this is what I'm very much interested in, also my group at ETH, what we are researching in. And actually, this can, I think there's a natural fit to cryptoeconomics. So for this collective intelligence, what is often or tried a lot and explored is like this DAO concept, like kind of open, low threshold governance systems, very inclusive. And on the self-organization side, what one can use is actually multi-dimensional token systems, which also has been a basically a major factor of my research, which I conducted. And so this is now coming over again to our global challenges. So one thing we observed is actually the problem is that the delta T is too large. Yeah, so I perform an action, I throw a plastic bottle maybe in the forest or in the river, and I don't see these massive amounts of garbage on the other side of the world, or even on our garbage sites here regionally. So like kind of there's a disconnect of our actions to the effects. And so this one can argue self-organization cannot really happen. Yeah, so and an idea is like we need kind of a information signal. And what is if we take as a information signal actually currencies? Yeah, so this was one of the directions. So what we did in this Finance 4.0 project was actually we extended the concept of money as an information signal. We tried to explore new monies, so to say, which represent different incentives. And we in particular let everyone design these new monies. So very simply, one can say, hey, plant a tree, improve it, obtain a token. And this was what we implemented in the software artifact. Unfortunately, I forgot to include the link here. So what can one do? So one could try to design currencies around different issues, and then have them provide feedback to individuals. And actually, our design principles in this research project were inspired by complex system theory. So we wanted to have multi-dimensional incentives because we noticed that having a one-dimensional currency, like for example, the dollar, where most currencies are based on, is probably not enough to control and steer a complex world. Yeah, so basically by trying to manipulate, the interest rate or the monetary supply, one tries to fulfill many different objectives, like having a strong industry, a good publication system, health, like all of these different things. And we think that by having actually different currencies, different dimensions, then the system can better self-regulate and maybe even better controlled or steered from a top-down policy perspective. And on the other hand, we really try to have a bottom-up creation of different currencies and kind of let the collective knowledge explore which designs are actually suitable. And of course, this was enabled by DLT, which in some instances actually this decentralized network of peers, and also having this democratic governance aspect on the platform. And so this was this, and cryptoeconomic systems. As you guessed, I see it as a subpart of, or basically one instance of complex systems. And there are many different research fields researching it. I'm seeing myself more on the computer science, economics, and psychology side. So this is my perspective on these systems. And so I researched them in my thesis, Fundamentals of Cryptoeconomics. And now in the next half an hour, roughly, I will present you the main contents of this research I conducted in the last years. So I addressed different research questions. So actually, because like these DLT systems, they're having a very large design space. I will have later also a slide on this. It's very different to identify what are actually the key design choices in these systems. So this was the question which I answered in this first chapter. Then I looked at how actually can a cryptoeconomic system be designed and implemented. And also then having a concrete application scenario, I implemented this methodology in a customer feedback system and then investigated the impact of this feedback system on human behavior in an information sharing scenario. And I used two research paradigms like the design science and behavioral science for this. So let's dive into some of the main findings and contributions. So this will be a very high-level overview and also quick. If you want to know something in detail, you can discuss afterwards. So in this first part, we designed a novel methodology to actually identify these design choices. So we started from a conceptual architecture, which illustrated the space of cryptoeconomic systems. And based on this conceptual architecture, we developed a taxonomy. This is a taxonomy. It consists of these four components: distributed ledger, consensus, token, and actions. And this one can illustrate different systems, like, for example, Bitcoin, which has a public right permission, and Ripple, which has a restricted. And as this was my main focus, like also one can illustrate these tokens. So for example, the Bitcoin token can be said, hey, it has a capped supply. It's created whenever a consensus action is happening, and the source of value, or at least one of the sources of value, is actually that one can store pieces of information in this distributed ledger, kind of which are immutable. We can also illustrate other tokens like Monero, Ripple. So, and when compared with related work, we looked at, we also included token properties in our taxonomy, which often has not been performed in the past, or at least at the time of writing. And where we come now, we evaluated this taxonomy by the community. So in order to do this, we first classified 50 real-world systems, and then we let the taxonomy and the classification be evaluated. And we found that the taxonomy is expressive to classify all and differentiate between DLT systems, and that the classification was accurate. So after the feedback, we also improved it and basically had then a very validated a data set of these 50 systems on which we applied machine learning to identify some properties or general design decisions. For this, we applied two methods. One is like k-means. It's, I think, familiar to most of you, and in multiple correspondence analysis is a generalization of the principal component analysis for categorical data. And what it does, it finds new dimensions based on the original taxonomy attributes, so that the variance which is explained by these new dimensions in the data is maximized for in a consecutive order. So the first dimension explains the largest variance in the data, and the second a bit less. And applying these methods, we actually identified 4 dimensions which explained over 95% of the variance in the data, which can be called layering. So is it the first layer or a second layer system, something in this direction? Participation, is it permissionless, can everyone participate, or is it permissioned, which actually extended the concept of permissionlessness only on the consensus, but also included, for example, actors. So like now your customer policies and like these kind of things. Staking capability, can the token be used or to participate in the consensus, and some related properties. And cryptoeconomic complexity, is one token used, 2 tokens, how do they interact, and these different things. And actually, when we use k-means, so the second method, we actually identify the same 2 dimensions as here. So kind of find the independent validation. And here we see these 3 clusters in these new dimensions. So we see here on the right, we see first layer systems, the permissioned ones on the bottom, and the public permissionless on the top, of which Bitcoin is a representative, and then these second layer systems here. Based on these 4 dimensions, we designed a design guideline. So kind of we have importance in decision making. So when one wants to design a new system, one should first think, hey, do I want to have a first or second layer system? What should be the participation? Do we want to have some staking in my system? And in general, what is the complexity, or how complex do I want to get with this cryptoeconomic design? In summary, you can say it's conceptual architecture and the taxonomy maps comprehensively the design space and enables the differentiation between systems. The classification informs about existing system configurations, so kind of as a source of knowledge can function, and these design choices limit modeling complexity at design time by structuring the design process. And overall, it's a novel methodology which can be reapplied whenever new systems emerge. We need to extend the taxonomy Okay. Then in the other parts of my dissertation, in this second and third chapter, the main contribution is actually a value-sensitive design science research methodology for cryptoeconomic system. So to build these systems considering the values of the stakeholders already at design time. And one can ask, hey, why these values, and a brief motivation. So actually, when one looks at this taxonomy, which is by far not capturing all the aspects of cryptoeconomic systems, but even this taxonomy already has over 2 million system layouts which it can illustrate. Yeah, so 2 million different systems which could be constructed. And actually, this is a huge design space. And how can one now, if one wants to start a new system or build something, reduce the complexity? And one natural way is like of saying, hey, what is the goal? So for some goals, not all design aspects are suitable. Another way is one can think in terms of attack vectors. If you want to protect against specific attacks, some designs are more favorable. Sometimes one has technical restrictions or even legal restrictions. So not everything is possible. And if one cares about the legal world or the real world outside of the blockchain, one needs to consider them. But actually, one way of also restricting this design space is actually by taking some normative stances, and based on which this complexity can already be reduced at design time. This is it's already an established approach in some fields of design science research. And from a different perspective, this value-sensitive design also makes sense, because if one constructs, or what has been found is, if one constructs a system which values which are ingrained in the systems are too strongly contradicting to the values of the users, that this can actually result in technology technology rejection. So if you want to design a system which is also used by users, it makes sense also just from a efficiency perspective to include these values at design time. So this is what I did, or we did. So we used an established methodology from design science, combined it with value-sensitive design. And I will just talk about the methodology here and this core part. So how one can actually go forward when one wants to identify some design principles, which then can result in this construction of the systems, actually, that one starts with a stakeholder map, maps the different stakeholders and identify those which are important. Then one can link to the stakeholders' values, like the values which are like the value space, and then identify which values are actually important for these important stakeholders. And then one can start identifying requirements based on these values. So then you have kind of value-based requirements on the system construction, or like for the system. And when one starts clustering these requirements, one can identify some general design principles, which, okay, I should have progressed here, but good. And so in this second and third part of my thesis, we use this developed this methodology. We also built 2 software artifacts. One is this Finance 4 system, which I briefly motivated in the beginning, and the feed for org. I will illustrate now a bit of greater detail. Let me see. Okay, nice. So I basically wanted to know what is actually the impact of these cryptoeconomic incentives on human information sharing behavior. And this was a full research question. So what is the impact of multiple blockchain-based tokens on human information sharing behavior measured in quantity, accuracy, and contextualization of the shared information? Because this is quite of a complex question. I briefly walk you through it. So what do I mean by quantity, accuracy, and contextualization? So these are three, one can say, dimensions of information. So quantity can be the bits and bytes in an information source and can also be measured in this way. As a contextualization is actually a different concept. So one can say, hey, we can have basically big data, which are like single pieces of information, which are basically stupid by itself and which need high processing power to be able to be reasoned on it. And what one can do is like kind of store these pieces of information in linked graphs, in semantic structures called semantic web or linked data ontologies. So these are different concepts here. And basically have information stored in a way that it can immediately be reasoned about without having the need of processing it every time, which is actually very important for our times right now, because like actually what one observes is that the computation power is not growing as quickly as the amount of information we are collecting. So we cannot process all information, which leads kind of to dark data and biases, because the programmers need to identify which data sources they want to use in their algorithms, which can result in biases in the end. And so this contextualization is one thing to address this, and one can measure it actually by counting these links in such a graph, for example. And the third dimension is accuracy. So how accurate is a piece of information, which is also like naturally important, because otherwise it would be just white noise giving us no meaning. And one can measure accuracy either by having a ground truth, which is kind of a gold standard. So you collect a piece of information or have a piece of information and you can compare it with something else. Often this is not what one has. And what one can do here is like try to collect different pieces of information from different sources and compare them and see if they agree. So in kind of such a way. And the main message is all of these dimensions can be evaluated quantitatively. Then information sharing behavior. So what I mean by this? So for this, I utilized this software artifact, which was created before. So this is like a very simple customer feedback system, which asks a question to the user. So for example, to consider taking part in an imaging campaign, and users can answer, give feedback to it. And the innovation or the novelty was that users could contextualize their feedback. So for each feedback, they could say, for example, how satisfied they were with the spectrum of possible answers provided to this question, which later on this library organization could reason on if the question on the meta level were posed in a good way or bad way. Maybe they impacted the way how questions were answered. And the core idea here was that whenever users answered a question, they received a token, which was called money token. And they received, whenever they performed a contextualization, another token, which was called a context token. And these were actually these multiple blockchain-based tokens, which are used. So there were two. The money token resembled, as the name said, very strong the fiat currency, the Swiss franc. So in the course of the experiment, there was a budget. So kind of the supply of this money token was kept, and it was pre-mined. So all of the tokens were in existence beforehand, and the token actually had value because it gave access to money in the end. Yeah. So for each token a user had, they received Swiss franc in exchange for exchange rate, which was known. And the context token, in contrast, was uncapped. So there was no cap on the supply. And it actually was created. So a new unit was created whenever users performed an action in the system. And the value of this token stemmed from two sources. So on the one hand, users could use this token to do some voting actions inside of the app. So having kind of a privileged access, which functioned as a source of value. And the second was reputation. So users could observe how many context token other users were collecting on the leaderboard, which functioned as a further source of value to this token. And then, we studied this scenario in a controlled randomized experiment, having a 2x2 factorial design. So how did it look like? So users had this app on their phone. They were allowed to go home and basically live in their normal environment. They could answer a question to these organizations and receive these token incentives as an exchange, and they could observe how many tokens other users were collecting. So this was a scenario of the experiment. It consisted of 3 phases. So there was the onboarding phase, in which a question, like a Q&A also happened. So they could ask questions. There was an entry survey. There was the exit phase where users could answer also a questionnaire again and receive the payment. And during the core phase, actually the information was collected. So, and there were 4 days. At day 1, we did not pay any treatment. At day 2 and day 3, we had these incentives, and at day 4, we had no incentives. And we had 4 control groups. So basically, we had the context token, the money token, and basically all combinations were possible. So we had a control group which did not receive any incentives. We had a group which received both token incentives, and 2 groups which only received 1. The study was got an approval by the ETH Ethics Commission, and we conducted it with the support of a decision science laboratory here at ETH, and the budget for these incentives were around 7,000 francs for 132 users. Okay, different variables were collected, so we had as independent variables these treatment groups, and as a dependent variable, we measured per day the quantity and contextualization of shared information. So these 2 dimensions we saw before, and over all the day, we measured the accuracy of responses. So we asked the same question more than once to the user and checked, basically it took, with a simple Jacquard similarity, how accurate they were responding to these questions. When we looked at these variables, the distribution, we saw that they were non-normally distributed, which made us use a non-parametric test, the Kruskal-Wallis test. And we also created some interaction plots to see the token impacts. And here come some of the findings which we obtained. So actually, the first effect which we noticed was kind of an interaction effect, which is novel or has not been identified as this beforehand. So what we see here, so here we see the quantity and here we see the contextualization of shared information for these 4 different control groups. And when we look at the medium quantity of shared information, we see that those who received the money token, they shared the most information, which was kind of expected. So we formulated hypothesis on the self-determination theory from psychology, so like kind of intrinsic and extrinsic motivation. And we know that monetary incentives increase extrinsic motivation very strongly. And because quantity is kind of linked to extrinsic motivation, this was kind of expected. And also on the other hand, those who, the control group, this was expected. But actually the thing which we observed is that the group which received both tokens, the money token and the context token, so the both group, that they actually shared considerably less information than those who received the money token, which was also significant by this Kruskal-Wallis test and the postdoc analysis, the difference here. And the same thing we also observed for the contextualization of actions. So the context token was awarded whenever a contextualization action happened. And we see that those who received the context token provided a lot of contextualization feedback. Nevertheless, those who received both tokens did not provide, or had basically provided considerably less contextualizations. So kind of these tokens are interacting with each other. And it's not like so simple to design these systems, because like if you have the knowledge how one token behaves and you have the knowledge how a second token behaves, when you apply both of them in the same scenario, impacts on emerging system behaviors might vary considerably. And yeah, we noticed also some other effects. I will not go here into details, but actually one effect which we saw is that the impact of token incentives can vary over time. Yeah, so like at day 1 or day 2, it might have a different effect over time, which one has to consider when designing these systems. One can also observe an internalization effect. So there was an impact of, for example, the context token on the contextualization action of users even after the incentivization period ended. So as you remember, we had at day 2 and day 3, we had incentives. At day 4, we had no incentives. And actually, the context token still had an impact on day 4. And we explained it by a positive impact on intrinsic motivation, which even lasts after incentivization stops. Nevertheless, we also noticed that what we already knew from the literature is that tokens can have a negative impact also on intrinsic motivation and basically crowd out intrinsic motivation, resulting in reduced performance from a system perspective. This can be basically summarized in these key statements. So kind of utilizing multiple token incentives can improve shared information when compared to a single token scenario. So for example, we saw that utilizing both tokens still, though reduced, results in a greater quantity information and also in an increased contextualization, like when compared to just single token incentivization scenarios. Nevertheless, the crowding out of intrinsic motivation results sometimes in setups where one would be better off not to use any token at all. So for example, measured in the accuracy of shared information, we see that the control group actually reaches the highest accuracy when compared to the other groups. So this also needs to be considered. And and what we also know, like, or basically, because it was not really seen before, this interaction effect has not been, maybe also for this community, I think not really been considered in token economic simulations, which are very often driven by a very game theoretical mechanism design perspective. And this impact on human behavior, yes, I think is worth exploring in simulations. And I will come to this later on. So basically, to summarize it, one can say that this thesis comprehensively illustrates and structures the complexity of cryptoeconomic systems. So we derive these key design choices. We have this methodology for value-sensitive design of these systems, and we also investigated the behavioral effects of tokens on human behavior. Okay, now I will come to the last part of my presentation. I think it will not take me more than 10 minutes. And basically, I'm always looking for cooperations. Yeah, so I'm very happy. So like if you see something, if something resonated, even if it's minor, feel free to ping me. But to make it maybe a bit more structure, or giving it more structure, I show you a bit where I'm up to right now. So in my postdoc position at ETH Zurich, I'm currently like looking out like into 2 research directions. So the one is like to design an agent-based model for these cryptoeconomic systems. So as I said in the beginning, my original background lies more like high performance computing simulations. So I would like to reuse this knowledge from there to now study these cryptoeconomic systems. So maybe design a tool for the community, but in general having the goal of redesigning a large agent-based simulation. So what I noticed is like, well, like kind of, but I think you are probably there much more aware that most modeling approaches right now, they're quite restricted in the size of, if it's an agent-based model, how many agents are modeled, sometimes also so to call just a system dynamics perspective. So having just few actors interacting and not really accounting for this complexity and the emerging nature of these cryptoeconomic systems. So like building the software artifact, reusing some of existing tools. So this is one thing I'm looking into. then I would like to use this tool to research multi-dimensional cryptoeconomic incentives. So I think it's a very promising direction, having this multi-dimensionality in these systems. Also taking some of the findings from the previous research, or kind of trying to obtain the same emergent behavior, like calibrating the model with these findings of the action effect like this, and then start exploring different types of tokens. And then linking a bit to the second project, also to study different governance mechanisms, which I think is also a very interesting research field. And here I would like to maybe have a kind of a value-sensitive blockchain governance by design, which is currently more a side project, also linking to my position in this startup, which I will be talking on the next slide. But basically what we notice is that when one builds these blockchain systems, one has these kind of very often very disconnected three worlds. So on the one hand, one has the political world, or kind of the ideal world, how things should look like, which is really driven by a empty field, and one just starts having crazy ideas and building stuff. But then when it comes to business, very often one has practical requirements driven by business, and making them both work together sometimes are conflicting, and it's difficult to find the matches. And then when one comes up with a working system layout, then often the legal point of view comes in. So, and this is like a own field on its own, and having there a combined approach, which kind of merges these three fields, I think is very would be very helpful for the community. And I think also from just a purely research endeavor would be interesting. Now to the second thing I'm involved in, this a startup in the blockchain realm, which is called Unocoin. So basically what we are trying to do here is to build a global and dense real-time kinematic reference station network. So what is this? So basically what we're trying to do is like to improve systems like GPS. So GPS is like currently accurate to 1 to 5 meters, which is not enough for some applications like self-driving cars or drone deliveries, like these kind of things. And actually there's a very established technology out there which can be used to improve this GPS signal. So one does it by placing a reference station on a place on Earth, which knows exactly where it is. It receives the same signal, which is often has an error inside because of weather, because of failures in the satellite itself. And then basically because the reference station knows where it is, it can calculate the correction to this signal and then send it to nearby devices. So like kind of this correction information. This is already an established market. So it's a very high-end niche market for like, for example, in coastal areas, one has this technology applied for these large ships which need to navigate there. In mountain areas, in the ski resorts, one uses it sometimes. You have high precision farming on some very large farms who use this technology, and land surveying and some more application domains. And what we are doing now, so we are trying to build these global reference station network, which is currently not existing. I can, if you're interested in this, I can talk a bit more about it. Some Q&A. Why not? But so what we're doing now, we identify this token economic model. We'll not go here into details, but it's highly inspired by Helium, the Helium project. So kind of it's, I'm not so sure if you're aware of it, but they built basically such a dense reference station network for LoRaWAN, for the LoRaWAN technology, which I think was quite impressive how quickly they did it and how well. So kind of we have on the one hand the technology from this GPS industry, and on the other hand, kind of a proven cryptoeconomic model. And what we're trying now to do is like to adapt it and to make both work together. We're having a very like a community approach, because actually, which is again from a research point of view very interesting, is that in this GNS or this GPS industry, so to say, this global reference station network is like kind of a tragedy of the commons. Everyone would like to have it, but the individual incentives are not really aligned to establish it, because like you have huge investment costs, like returns are coming at the very end of the life, of this whole process. And yeah, so like up to now, we did not identify established players who are opposing these ideas. And so what we're trying to do is like kind of making a commons out of this, like kind of having a community which governs it collectively. This is our model. Also, like in the Q&A, could go into details. We're using quadratic voting to kind of prevent power concentration, to really have like kind of at least a decentralized network, still having token-based voting, so one can increase its voting rights with more tokens. We have a proof of concept, still very centralized, which is up and running, so one can check it out here. And the gray part is currently what we are actively working on, like decentralizing different parts in the system. This is our journey. So next mid of next year, we would like to have MVP. And if something resonated here, you're interested to join us, to support us, contribute, maybe a researcher, some aspect might be interesting, let me know. We are very transparent and open, also like to share data. Whom would you be joining? I would say we have a very experienced and knowledgeable team, heavily also rooted in the industry. Dani, for example, he founded a successful business, uBlocks, like based here in Switzerland, having over 2,000 employees, and this is like kind of his new research endeavor. We have on the GNSS side experts like who working in these fields in several years, from the business development, people from this industry. Cryptoeconomics, we're still growing. So we are currently three people. So one person is missing on this slide actually. And yeah, this is for this. And then my last thing, I remained silent up to now, is like I also love to lecture. So I have a lecturing position at least supporting research here, teaching here at ETH, but also I'm at the University of Applied Sciences in Vorarlberg, where I'm teaching a course in general, like the overall like take on these cryptoeconomics systems is like kind of, I see it as blockchain-induced new economic thinking. And I'm always looking for speaking opportunities. So if I can contribute to your course, something, or speak to your crowd, let me know. I'm always very much happy to do this. But I'm also looking for people supporting in my courses. So if you have something you'd like to present to an interested group of students, some specific aspects you'd like to talk about, let me know. And maybe we find some opportunities. So I'm also looking for this. And having this set, some publications. And now I'm very much looking forward to your questions, feedback, and of course, comments.
So let me thank you very much, Mark, for this insightful presentation. It was very entertaining and very informative. Thank you very much. You've done a great job. So I have a lot of questions. I've started posting them into the chat already, just to start up the discussion. And we could go with them first. Like there are already some questions connected in the chat, but I would also encourage everyone who is still in the call to either raise their hand and ask a question out loud, or just type it into the Slack, into the chat, so that we can forward them to you. Very interesting presentation. Thank you a lot. What I would like to know, what interests me most, is the transition between the theoretical framework that you've done into your practical application. So my questions have been centering around them. Feel free to answer this, right now, or you can get a dedicated question from the chat, whatever you please.
I don't, because like I'm currently just on my laptop, so I can't see the chat really. So either
cool.
you just ask me a question, or I need to stop the presentation, but maybe we need to go back to the slides. So maybe just ask a question. And I will try.
So let me just read out the comments in the order as they appeared in the chat. So first of all, we had some compliments on your beautiful visuals. Like this is also happening. So congratulations, congratulations on that. But the first question comes from Jacob. He says, "Thanks, Mark. Question, from the cryptoeconomic perspective, we see that the BTC is the first successful system using cryptoeconomic incentives to achieve certain properties. However, BTC doesn't seem to characterize as a complex system. Would you agree on this? If not, why would you classify BTC as a complex system?"
Yeah, I mean, you have different security properties. on the system, which is not like by design. So like, for example, the immutability of entries inside of the distributed ledger. So one designed the system maybe, but still it's kind of the human behavior, like which in the end makes entries immutable. So we could just by vote, all not network participants could say, hey, we want to change something or censor something, and this could happen. And it's actually not happening. And I think at the beginning of Bitcoin, it was not so obvious that this would emerge. And like in general, the whole governance of is very much decentralized and not so structured, which makes it, in the end, maybe it's getting more simple over time, and this kind of could be argued. But I would, basically, I think there's some security properties connected, which are more emerging than really hard ingrained inside of the code. And also the governance by itself is a complex endeavor, I would say.
So it seems to me that you cannot answer this question clearly with a yes, right? Like, so Bitcoin is not really a complex system. So like, at least this is what I got from your response. So if this is not the case, which well-known, well-established crypto system would you then classify as a complex system? So what would be the first that comes into your mind when you think about it?
I mean, I would go back and say I think Bitcoin is a complex system. Like, I think by nature, because you have like all these human interactions inside of it, and also the interaction with the environment, like having from the impact on energy to all these things, like which are then again coming back also to the system itself by maybe regulation and trying to censor it. So I would say the whole ecosystem is a complex system. And then I would say that all the systems which are larger and kind of have impact on the environment, and which where people are interacting, they are complex. I would argue for this.
Cool. Okay, so we've got this clarified. Thank you very much, Mark.
You're welcome.
So let me read out the next question, which is actually from myself. So I asked you, when designing systems based on the classification presented in your research question number 1, so the first part of your thesis, to which extent does this overlap with the actual economic mechanism and incentive design of the application you are building? Which means, in other words, applying your framework in practice for token system design, what do you learn from those theoretical foundations you've created?
Mm-hmm. So like, basically, you mean by these 4 design decisions, yeah? Like, this is probably linking to them. So, I mean, these 4 design decisions, one should say they are kind of quantitatively derived. Yeah, so it's basically looking at these data. And I think one of the things which were also like already discussed before, like in literature, was like having a first or a second layer system is kind of, I think, a very important question. So should you reinvent the wheel or not? And I think this was kind of lying obviously in the space, and which was basically also identified by this quantitative approach, that they're like systems which are hugely differentiating itself based on this characterization. But which I very much like to see was what I also briefly mentioned, is that that this permissionless concept is not only connected to the consensus, but the overall design of the system. So like, also can actors freely enter? So can they just start like downloading a client and use the system, or is there some kind of gate through which one has to pass? Also, who can read the entries to distributed ledger? How transparent is this? Also plays into this concept, which was kind of emerging, which kind of made me at least think also differently when one then starts designing the system, to also see these different aspects. And unfortunately, what we did not or do not have in this taxonomy are like these different governance aspects. Yeah, so like this taxonomy definitely could be extended to this, and I would hypothesize that also the openness of the governance would probably be connected to this permissionless concept, which is more or less left to future research. And at least, and it was also just a snapshot. Yeah, so we collected the data 2018, 2019, already some time ago. And this cryptoeconomic complexity was a dimension, but like just a fourth one. Back then, I would have hypothesized that this would increase, and I'm currently not so sure, but also not having the full overview anymore, because I still have the feeling that usually, I'm not so sure, but very often people tend to design simplistic systems, which I think is also good and probably should be done. Kind of, one should more have an iterative approach of adding complexity. But I would expect to see more systems exploring the full design space, which one has, like also introducing maybe more than one token. The Helium network is doing it a bit, so they iteratively introduced new things. And so this is like something which also made me think into this direction back then, that this at least the cryptoeconomic complexity seems to play a role, in which sense one need to see probably.
Yeah, so you made two arguments here. So the first one you made is that it's the same as with decentralization, right? So you can call a system only as decentralized as the weakest link, right? So if the consensus mechanism is decentralized, but the decision making, the governance is not, then you wouldn't treat it to be a decentralized system. And you said the same about the participation, right? So if it's like the weakest link is what drives basically this definition. But coming back to the question that I asked, so if I got you correctly, you said this was the first part of your thesis, right? So this was also the first part of your research. So you started your journey into cryptoeconomics with this empirical analysis of different system and this classification, right? So this is what you did in 2018, 2019. So now the question is, since you're working on applied research projects, how does this translate, right? Like, so now looking back at this, do you apply this framework on in your project? So like when you approach like this Onokoi project that you mentioned or other projects that you're working on, and did you come up with the same solution to the design applying your own framework, or was it just for you, just, like a good, interesting knowledge that you had, but you would have changed, you would have, so much more now that you would do it slightly differently?
No, like, it really became, like, I would say, implicit in my thinking. So I think even before, like, you have this framework also from Wüst, like basically saying, do you need a blockchain at all? So that kind of is the first step. But then really thinking, like, you need to think about, do you want to have your own blockchain, like maintaining the consensus and all the complexity which still comes from there, or if you want to build a second layer system. And basically all the project I were involved in were second layer systems, because like in the end, when you look at it, when it goes more into the incentivization of actions in the real world, I think I would say probably by now consensus, or like having your own blockchain, is really when you try to innovate the consensus, maybe having kind of a useful proof of work there or something like this, like really trying to reach consensus, maybe also in system states, then maybe constructing your own blockchain could make sense. And then, and then I was like, connected to the staking. Do you want to have staking in your system? It's like a question which is also appearing very often. So I would say I go through these steps, but they also, I would say at some point become very implicit. I think most people who design systems kind of think in this way. And by this is informed the later stages. But I would say what even more informed the construction of systems now is like this value sensitive design and methodology, which was also like developed, like kind of taking more, a stakeholder perspective, and then trying to design systems coming out of this perspective, like from the one side. And this is
cool. So let me follow up with another question, because this fits perfectly into it right now. So there is another question coming in. In your daily work as a token engineer on applied projects, which theories and methodologies do you find most useful to design and validate token systems? What would you recommend someone to focus on who is new to the space? What are the most relevant competences projects need? What are you yourself planning to extend your knowledge of in the future?
Yeah, very large questions. I mean, I would not say that I'm the biggest expert, like having knowledge on, on like what, or like how, like on many different projects. So I had up to now 3 projects I was heavily involved in, and maybe some minor ones at the side. But I see it, like, because like probably is also the methodology we came up with, but taking this value perspective is in designing these blockchain systems, I think, very important, because very often you're trying to design an open system, or at least a system which attempts to motivate many people to join. So you kind of need to think of them also already in the beginning, and taking this value perspective simplifies some aspects because it boils down to important questions. You ask about validating token models, or like what one comes up with. I would see, like in my personal view, like in the end, you need to implement them and test them, ideally in experiments, before you apply them in a larger scenario. But you could also go directly and see it as a big experiment. So I'm like, when it comes to token engineering, more on these, on the lab experiment side. Nevertheless, I see the benefit of simulations to inform different steps, and I see them like kind of going hand in hand, which is also like the reason why I'm now going a bit back to these simulational models to see, and also to compare like how accurately one can actually come to reality, or get guesses on design, which then can be implemented. So I would strongly argue in testing your system, like with real users, collecting data, and then see if it actually behaves as intended, and then going also like having this as a validation besides of simulation, because I think just simulating in the end is not, you're not able to capture the whole complexity which is inside of the system.
Yeah, but it is tricky to simulate to test something when especially in token systems, most of the things, decisions that are implemented are final, right? So you would implement something on chain, you would allow users to interact with your system already, acknowledging that what you've built is just a prototype because you are testing what you're doing, right? So there is this ambiguity between how far you want to proceed with the implementation of the test case in real life versus how much simulation support you need.
I totally agree. And out of this perspective, I think there would be a huge benefit, like already analyzing all the systems which are out there in greater detail and really analyzing them. And like, I think like open sourcing data in this perspective and having them, or like making it, most of them are open source, but like kind of making them easier to analyze would, I think, be very helpful to also inform new system designs, because I think a lot of things already have been tried, and very often one just reinvents the wheel. And so I think.
Cool. Let me follow up with another question that also again fits to the topic that you are, to the thing that you're talking about right now, because the question is, what are your ambitions in the agent-based modeling framework with respect to mechanism design validation versus system evolution investigation or prediction? What existing software tools are you building upon? How do you ensure to have realistic assumptions about agent behavior? So there is this, the stance that you have to take at some point and say, okay, I'm assuming some agent behaviors, and this is what I'm modeling, and this is what I'm getting, versus I'm doing some real lab or field experiments to get to know the system and user behaviors in this situation. So how do you want to align all of those perspectives in your research?
So like basically we're still early in this process and like of designing this tool. So like there has been a first technology stack like being researched, but also looking collaboration like in this domain. But how I see it currently is like there's like this repassed HPC library out there. So it's like kind of a established agent-based modeling tool for large clusters. So like not necessarily this one, but like it's like having something like this and then building for the community on top some interfaces to use it. And here one could either, I see it, using established simulational tool. So like there's like Mesa out there, but there's of course I think you also know like CutGut. So maybe one can combine them. I didn't look too much into it because like in the end one already needs to think of scalability at design like so kind of so what I'm trying to do is like kind of splitting the computational domain and finding natural units which then could be distributed, and then to calculate them I could also talk a bit like I have maybe a slide somewhere on this. So this is the first thing, and then from the agent modeling perspective I would go probably in the first iteration for some behavioral agents, so kind of having some probably behavioral rules inside of them, informed because like this is basically where I'm coming from this self-determination theory. It's like probably I would model them with intrinsic, extrinsic motivation, but this goes already to the very, so not the software artifact anymore, but to the concrete thing which I would study, and then take this abstraction of intrinsic, extrinsic motivation and see if we can find here a model which reproduces these findings we had in the lab experiment, and then at a later stage ideally change, for example, the tokens with having new assumptions on these intrinsic, extrinsic motivation, and then trying to play around with different tokens, find maybe a new combination which is interesting, and then research this combination in a lab experiment, because right now was a very random choice for these tokens, and there's a design space is huge, and basically identifying those designs which are interesting or which are from the simulation wise interesting, then to study them in real world. So this would be how I would go forward here. And then later on, I think there are like extension different ways. One can also have cognitive agents. So maybe you could even introduce learning, like all of these things, but I think this is very, very much to the future.
Yeah, this is ambitious. Yeah, and to which extent are you planning to bring this on chain as well, like in the sense of applying in real world projects, or is this solely intended to for research purposes?
So I mean, you mean what we are simulating, or the simulation itself? Because I think the simulation itself will be off chain, at least. So how I see it. Yeah. So I think like starting from this toy model or like these lab experiments, like kind of calibrating things, but I would be also very much motivated to simulate real world systems. And one of them could be this Onukoi project I am in, because we have a very detailed understanding of how maybe some agents would behave. And using this as a case scenario, because I'm very close to it. But if there's someone else who thinks a very good use case, also look into how to study this one. But like as I said, like I think it will take some time to build the simulational backend in the first step.
Yeah, so this is mostly the challenge, right? Because like the project wants to make progress. On the other hand, research takes some time. So like this is why I was asking about how applicable are your results?
But I think for the moment, I think Europe probably also very aware of it. They're like very, like I think like for example, CutGut is a very useful tool, like to start off. So I see it like kind of as parallel streams. So one tries to first model very or more simpler model, and then over time tries to make them larger. And at least for small, maybe even medium-sized models, I think one can also use CutGut as long as it can run on one node, basically. And already, but then again, it's then very, very simplistic model. Then it's really the question how closely it models the real world. And also this, I think from a research point of view, would be very, very helpful to know how well simplistic model compare to these more larger models. And I could even imagine that maybe in many cases, one does not even need to have these large simulations and could just stick with these simpler ones. And we are also analyzing here the trade-offs in the context of cryptoeconomic systems would be interesting.
I see. Yeah, I agree with you. So we have a question from the audience regarding your simulation assumptions and your simulation research approach. Why weren't interaction effects being considered on token economic simulations? shouldn't these simulations have the purpose to infer the macroscopic outcomes of a system given agent decisions on given constraints?
So yeah, so why they have not been considered so far, you asked me. So I mean, I think it's not implicitly obvious probably that they are there. Maybe they are. I'm not so sure on this. And I think in general, token economics simulations are very much driven by game theory and mechanism design. So starting with very simple model and then extending them, and going, yeah. So basically, these mechanism or mechanistic designs, like you really enshrine the behavior. So you put a lot of assumptions inside of them. And on the other hand, in these large agent-based simulations, I see more that you really start to implement the local interactions just between the agents and less on the mechanism which you put on top. And maybe from this view, people were not thinking, but yeah, I don't know. I think it has not been really known beforehand that these tokens might interact. And I maybe one would say intuitively, I have one token, it has this impact. I have a second token, it has that impact. And now I take two tokens together and they have combined this impact, and that they might deter in some dimensions the properties of the system. I think it's not so obvious.
Yeah. I see your point. So, you know, my opinion as well. So my opinion is that right now, as of right now, in the token design space or in the implemented systems on chain, we are in a very exploratory phase where mostly we only focus on mechanism design questions, right? So like we want to have very robust systems with lesser focus on actual agent behavior. So like we want to make sure that we have a DeFi protocol that functions regardless how people would choose to act, right? So there is so much left to be investigated in the future. Once we have built those robust economies, we can transition more towards investigating how agent behaviors and interaction behaviors can have an effect.
I would see here, I would say yes, this is definitely valid, but I think all simulations in the end, just because like in the end these are socioeconomic systems, in the end it really depends on the humans how they use them, and identifying, like designing a system such that it cannot be breaked or not be hacked or in some form, I think is tough. And so on the one hand, so I think it's very important to already see like users' behaviors at the early stage, just to account for this. And on the second hand, I think if one just takes this mechanistic view, one tends very often designing maybe efficient systems or like optimizing in some specific dimensions. But like as what I was very interested in is like this value approach. Yeah, so like maybe we end up building systems which work very well, but in the end they are not according to the values of the users. And here having this view also very early in the simulations could be beneficial when it comes to technology adoption and like these kind of questions. So I would not fully ignore these questions, at least.
No, I'm not ignoring them. I'm just stating that currently, when you see what the token engineering space is evolving around, those questions are not so much in the focus.
I totally agree.
Yeah, so this is why it's so vitalizing having you bringing up those questions and those perspectives into our community. So I'm just acknowledging that this is a very overlooked so far perspective that we haven't incorporated. Tiago, you came up with this question. Do you want to follow up on that? So I can unmute you if you want if you have something more to say. Oh, he can't because he's in the library. Okay, Tiago. So enjoy your your quiet environment, and thanks
for the question.
Yeah, cool. Okay, we have one more question here in the chat, which is: can we use data on the existing projects that are recorded on the blockchain and model different kinds of agents and scenarios about how a system would react? Can we use some machine learning to get some models based on the existing data?
I'm pretty sure. Yeah, I would answer this with yes, but it's a very tedious work, and yeah, Yeah, but yeah, this is definitely possible, I think, and it's also done in like I know that, for example, Claudio Tessone at the University of Zurich is using a lot of on-chain data to look on power concentrations in this network and how power concentrations evolve over time and like this. So there's definitely research done in this direction. Yeah, but it needs to be done.
Yeah, I do agree with you. So from what I've seen, yes, this data can be used to learn agents' behaviors and to backtest system models and improve the understanding of simulations. Yes, this is tedious work. Yes, and it's a trade-off between new mechanism design and changes to mechanism design versus what can you learn about existing agents based on the data that you see, right? Because if you find an alternative mechanism design, an alternative solution, you cannot test it with the data that you have because it is a different, like to some extent only, like your possibilities are limited here. So
this is in general with past data predicting the future. So because I think it's the end of the philosophical question how unique each moment is. But I think I also totally agree that there's some limitations of having past data explaining future behavior. So like I think but also here like having quick feedback loops. So like also like when one designs these systems, like being able to adjust and to adapt or maybe decide not to adapt, like in the case of Bitcoin. And like fossilizing some aspects. But these are like all things, which one can, should incorporate.
Cool. Perfect. So those were all the questions from the audience we had today, but I'm very happy to open up the floor if there is anyone who would like to ask a question right now spontaneously or just say anything. Please raise your hand and you can follow up.
Otherwise, you can always ping me. I have.
We have.
Yep.
We have one more question. We have one question just came in right now. I am not sure if I got it completely correct. One of the results indicated that the interaction of two tokens might be better than having one. If I got this right, this would be a money token and a context token. Does this imply that tokens used both to govern and for money, ETH, for example, might not be efficient?
Again,
does this imply that tokens used both to govern and as money in the system might not be efficient? And here the person is referring to Ethereum, for example.
Yes. Yeah. So maybe. Yeah. I would probably argue in this direction because like with money, you always have a very strong link as an extreme, like this crowding out effect, which we observed is basically money very often crowds out intrinsic motivation. And intrinsic motivation is often intrinsic motivation is predicting like joy, but also creativity, but also endurance. And maybe endurance you would like to have in a governance setup. And mixing here too much into one token could impact intrinsic motivation negatively, which on the long run would change governance behavior and like these things. So I would say, I think like, and I think it also splits up a bit complexity because like when you have then two tokens, you can easier change one without impacting too much of what the other token is impacting. And I think it's at least a worthwhile endeavor to explore how like increasing the amount of tokens and really clearly separating the purpose of each token from each other. I think this could then make the modeling maybe or the implementation a bit simpler in the end.
Yeah, I do agree with you. I don't want to put you on the spot, Julia, here, but on our side, Julia has been doing some research on, disentangling the effects of different tokens and their purposes, especially with an eye on, if you have multiple units of account or if you have multiple units in the system, you can easier design control mechanisms that can individually target particular goals, and you can achieve those goals separately. So I don't know, Julia, if you want to add something on that, but this is the thing that you came up with when you worked on this internally, right?
Yeah, it was a lot of what we was talking about with this particular client, and yeah, we came to the conclusion that it was actually a lot easier to disentangle everything with the two different tokens. But at the same time, people often want one token to capture all of the value in one place. But I actually have one question as well regarding to this, because you said that the extrinsic motivation kind of harmed the intrinsic motivations. So if, for example, you would use the token incentives for environmental or social impact, will it over time increase people's willingness to just do it good?
Yes. So yeah, so basically one has like, so it's like it's just a model, yeah, but basically modeling people as having intrinsic and extrinsic motivation, and then tokens can impact these two factors differently. Yeah, so and maybe one token impacts just one and the other token just the other, or maybe both. So like, for example, one knows that money very strongly positively impacts extrinsic motivation and negatively impacts intrinsic motivation. So this is like kind of really a fact from many experiments conducted. So when you design a token which is like money, then you would expect the same thing to happen. Yeah, so like kind of increasing extrinsic motivation, decreasing intrinsic motivation. But on the other hand, we know that, for example, reputation, something which is like functions like reputation in the system, is has actually more or less no impact on extrinsic motivation, but a lot on intrinsic motivation, and can actually enhance intrinsic motivation. Yeah. So and now you have these two tokens, like so, and then you can make blends in between and see. And so this is like now, and this was the motivation for these studies. So having one token which is like money, kind of the entries like to the work which has been performed, and then having a token which is very close to reputation, but was not really like reputation. Yeah. So you could transfer it from one to another person. So and yeah, so like yeah, so I think this
but then you would argue that if you have a complex system with multiple effects that you want to capture or incentivize, you would potentially need to ramp up with your token numbers, right? Like token types, you would need to have multiple instruments in the system achieving this.
Yeah. It's like, I think it's really still very early, and it's really enjoying. Like I have some slides. I will not talk about them now, but like I think really like disentangling here, like I basically show with these examples I had before, how basically having 3 tokens makes life from a modeling perspective much easier than when compared to 2. And I think it's really what you really came up with is like really, because like if you have them separated, then you can easier control for different outcomes. And it's like really taking this complexity science perspective. So having more than one control variable makes it easier to steer the system into a particular direction, or even to enable to self-regulate when you see it as a feedback.
Yeah, but you must not forget that like you can disentangle the effects between the tokens and the outcomes and the controllers, but then you have interaction effects between the tokens.
Yes. So then you add complexity again, and
yeah, but this would be actually like, so when we talk about this type of question, so this would be actually one topic that I personally, and I believe we as a team would like to investigate further, because this is showing up with a lot of the projects that we are working on. The questions with regard to how many tokens do we need, what is the role of each token, and what are the functionalities of the token, how to control each of the token, and those type of things. So I would be very much interested in some scientific foundations in those disentanglement of effects between your instruments in your economy. So
so I'm here from applied side very early. So I basically I definitely have a background or a lot of knowledge, like coming from this self-determination theory and the intrinsic and extrinsic motivation, and here having different impacts. How this plays out in the crypto world, basically, there's like this one experiment and some work I'm doing right now, but so there's, but we can discuss on them and see how one maybe can design some new research questions or new applied guidance for practitioners, how to use the things we already know. Yeah.
Cool. I need to catch up a little bit with the chat because we had some questions coming in. So first of all, there is one question. I'm really curious about your Onokoi project. You just briefly described as a quadratic voting system, which I find it to be different from Helium project. Could you share a little more about it and explain why did you make this change in design?
Yeah. So it's like, I have backup slides, but I would need to find them. Yeah, so like basically, yeah, so Helium is like different on several layers, but I think they are now also introducing some on-chain governance and like these things. But why we decided here for quadratic voting is basically that we really would like to have a decentralized system in the end. So kind of really a commons approach. So protecting, asking against someone who would take majority control and then maybe steering the system into a different direction. And here we found quadratic governance as very promising. We're applying it in a bit of a different setup than it was maybe used in other, like even blockchain unrelated projects. So there were some, for example, very often you have like 100 tokens or something like this, and then you can split it on different projects, and you kind of encourage to decentralize or distribute your votings, because then you would have more impact than when you would place all your votes into one. Here we're not doing this, yeah. So we are just reducing the power of a voter, and the motivation is here that but this is like just a hypothesis and kind of a very good informed hypothesis, but that we through this probably can better steer this collective intelligence, because we see all the opinions of stakeholders in the system, not only by the one who owns the most tokens. And and because we in the end also decided for a 2-token system, we have in this UNO token voting and also some economic parts. And this is kind of how we try to dampen a bit the effect. So on the one hand, you can have an economic advantage with this UNO token, but this economic advantage in terms of returns does not translate one-to-one in voting power in the system. Yeah. So so this was the reason for it, and the motivation. If it works out, I would like to simulate in the first place, then to study it in experiments, and then to deploy. But here we also split. So this is like kind of our working hypothesis. And but the nice thing is actually that we also managed to combine this with a legal framework here in Switzerland. So we will be starting with that, going more the way of directly trying it out and then seeing how it develops over time, but probably similar to Helium, having most governance decisions in the beginning off-chain, and then over time increasing the things which are on-chain. And nevertheless, the things which happen off-chain already follow this principle here. Yeah. And
Cool. So final question, because I want to be mindful of time. There is someone who says, Mark, thank you for sharing your research process and insights. Would love to hear more about what types of domain modeling can best help identify what dimensions it makes sense to tokenize for.
Yeah, I would love to explore together with you.
Okay, but was there a question? So would love to hear more about what types of domain modeling can best help identify.
So what I got, okay. So it's a question, what type, so what's exactly the question?
There is no question mark, so it's difficult to read. But
yes. Yeah, so I think they're probably, but I would say, yes, there are probably domains where it makes sense to use a token, and probably domains where it doesn't make sense to use a token. For example, like this very information sharing scenario which we had from a very abstract point, if one could generalize these findings to other information sharing scenarios, which still needs to be shown. For some scenarios where you maybe just want to collect very accurate information, not using any tokens, probably more important or better, but then you would not have so many responses, and then finding a trade-off, and then we're looking for which scenarios these make sense. And for a domain where you already have a lot of data, or actually too much data, monetary incentives don't play a role so, because they would just increase the quantity. And so I think, so one would need to then look on a case-by-case basis, in which domain what could actually apply these things. And here, you need a lot of domain knowledge, I think, in the beginning.
I see. Let me read out the question one more time because this person rephrased it. Maybe this is the thing that you answered, but maybe it's not. So the question is, what domain modeling technique help you identify what dimensions to tokenize?
Which domain modeling technique?
Yeah.
I think I don't have like, it sounds to me like a very particular methodology, and I'm not aware of this one. But what we did, we basically, we mapped the stakeholders. We had these different values and objectives, and also different properties of the systems which we want to reach. And then we took tokens to basically address for this. So for example, we have in our system a very conservative user. I would say probably like comparable to Helium. That's the reason why we also, our token model is inspired by Helium. So we're having this burn mint equilibrium. So we're having one token in the system, the COI token, which is, yeah, it's basically in the end not really anymore. Well, it's a token, but it's not like in a classical token. So you cannot transfer it. It's more like a data credit. You cannot send to someone else, which is very closely related to some stable prices in the system. So like for this conservative user who does not want to know anything about crypto, so they just want to use our service, yeah, they basically could buy this COI token and then you like through some background mechanism. So they just send euros, they get COI, something like this. And then they would have a predictable usage time to this COI. And this is basically what the end customer wants to have. They want to buy some credits and know for the next half year I can use this service, independent on what the token, what the crypto market does, if there's a breakdown or price appreciation, so they don't care about this. And basically this was a very strong motivation for having these COI token in the system. And that's basically how we approach these things. So we try to get a deep understanding of the stakeholders, also of what we as a system want to have. Here also the UNO token played a role, and then we try to match it into a model, got inspired by existing token layouts. And yeah, but we did not utilize here an established methodology, more like intuition. And if you have something which would make life easier for the next time for me, very happy to hear about it.
Perfect. Thank you very much. So I would like to close the session because we are 10 minutes over time, and also we have covered a lot of ground today. But I also would want to continue the conversation. So we've set up the Discord channel especially for that. There is a research channel in the Discord, on the Discord server.
I will join it. Yeah.
You are here already, Mark, I guess. But there is this research topics channel, and in this research topics channel, we would like everyone who is here in the call, but also everyone who watches the recording and didn't get the chance to attend live, to just be able to reach out to you, continue the conversation, and get to ask your question, get to ask you how to collaborate with you, or invite you to other talks and so on and so on. So this is the intent of our meetup series, just to connect practitioners, projects, and researchers. And thank you for starting this with this talk today, Mark. Highly appreciate this.
I also really much enjoyed, and it's rarely that one gets the opportunity to talk about all these topics in one presentation, because as I said, you usually need to motivate it from different directions and take long, and then you cannot. I was able to show all the things which are important to me in one presentation, which already says a lot about this crowd here.
Perfect. And if you're interested, and if you want to deep dive into one of the particular aspects in the future presentation, you're more than welcome to continue in our series. So we can think of something like that. Let's see how much responses we will get in our community and what the conversation goes from there on. And if not, I'm sure we will catch up in some time when you have new research results ready to share.
Cool. Thank you very much, Chris, and everyone from Token Engineering Labs and the crowd.
Thank you so much.
Bye.
Thank you, Mark.
Welcome.
Thank you, Mark. It was really good.
Thanks. Okay, then I will